Welcome to the project demonstration of solar smart farming system using IoT. So in this project we have the features like uploading sensors data to the ThinkSpeak using ESP8266 module and automation of irrigation motor based on the moisture content inside a soil, and also automatically rain roof controlling system by using the rain sensor. So these are the main inputs and outputs to the microcontroller. And here we are using PIC16F73 microcontroller, which can control the input and output modules, and the whole system powered by the 12 volt 1 amp battery, and which is a rechargeable battery. So coming to the sensors, we are using soil moisture sensor to control this motor through electromagnetic relay, and a DHT11, that is humidity temperature values, will be uploaded to ThinkSpeak and continuously displayed on this 16:2 LCD screen. And this rain sensor used to detect the rain, and microcontroller will control this roofing controlling system through the L293D motor driver, as it will be driven by the DC motor. And the next thing is we are going to provide the power supply to this battery through the solar panel, and power will be given to the battery through the charging circuits. So here the rechargeable battery can be charged to the transformer or a solar panel. So let me show you the demonstration with transformer. For that, disconnect the S from this section and connect the T at this point and provide the 230 volts input to this cable. So the transformer will step down the 230 volts AC to 12 volts AC, and then it will convert to the DC, which is sufficient to charge a battery. And while charging, if you want to disconnect the power supply, just disconnect the power supply at this motherboard 2 pin, that's it. And then it will take 8 hours to be fully charged. And after that time is completed, you can just disconnect that. And let's demonstrate the project with solar panel. And now disconnect the transformer from this point, and we need to connect the solar panel. This is a solar panel connection. So we are using a solar panel of 12 volt 5 watts, and next this back to the motherboard. These two are the very important. And after that we need to connect one more S to the charging circuit. Now it is completed circuit. So 12 volts 5 watt power is given to the charging circuitry, and then we are going to provide the constant power supply, as we are providing variable voltage source, and the capacitor will make little bit constant power voltage, then that will be given to the 12 volt 1 amp battery. So here we can see the 4 volt 1 amp battery pack is connected in series. So we'll get 12 volt 1 amp, and the output of this given to the same charging circuit back, and there we can see one 7805 regulator, which will use it to regulate the 12 volts DC to 5 volt DC, as we require 5 volts power supply for the all input and output modules. And once we provide the 5 volts power supply to this motherboard, so the motherboard start reading input from the input sensors. So let me explain the input sensors, like pH sensor interface at A0 pin, A1 to the voltage sensor. So this is the voltage sensor board, which is a 10:1 potential divider to measure the voltage from the solar panel directly, and that is given at A1 pin. And A2 pin is interfaced to the rain sensor, and A4 for soil moisture sensor, and next C0 for DHT11, and C1 C2 for L293D motor driver to control the rain roofing system, and B0 B1 for the ESP8266 module, and next C7 to this relay to control this motor, and B2 to B7 for the LCD display. And on this motherboard we will see one more regulator, as we are using ESP8266 module, it will take more power. So that's why we are going to use the two L7805 regulators to provide the maximum power. And there we can see one reset switch. So this is the reset switch to restart the microcontroller. And next there we can see one crystal oscillator. So the steel plated one is a crystal oscillator, which will provide the clock pulse to the microcontroller. So as we are provided some instructions to the microcontroller, so read the inputs and controlling the output modules, and then the microcontroller need a clock pulse to execute the instructions. Means one instruction to be executed by the one clock pulse. So like that, microcontroller will execute 20 mega instructions in 1 second, as we are providing 20 megahertz crystal oscillator frequency to the microcontroller. So the red light is power LED indication, and a green LED is a program LED indication. So before switching on this switch, we need to enable the hotspot in your phone. So go to hotspot settings of your phone, and next change the hotspot name to project 4852. Right. Go to the hotspot settings. Yeah, right. Change the hotspot name to right. So now change the hotspot name to project 48. Right. So project 4852 without any space and without any capital letter, and a password should be 129. So it's very important. Check twice before switching on the hotspot. And after settings has been changed, and now on the hotspot, and also enable the data. And after that, log into the thingspeak.com with given credentials, and you can go to your channel, and in that go to the Iot Smart Farming. There we can see our data of like temperature, field 1, and field 2 is humidity, and next field 3 is rain and moisture level, and next solar voltage and pH. So these 6 parameters will be uploaded. So while we are seeing the data in mobile phone, just we need to touch on this blue line only. Right, now switch on the power supply to the system. Right, so after switching on that, there we can see the welcome message on the LCD screen, and after that, so we can see the temperature and solar panel voltage and humidity in percentage, and the next pH value. So now we are placing the pH sensor in water, dipping into that, and next, as we can see, the water content is there in the soil, so that's why the motor is off state. We can see there is no light indication on the relay. Right, we can see that relay got switched on as there is no water content in the soil, and when I dip it back, then automatically it will be off. This is the automation for the motor. And next, coming to the rain, so there is no rain here, and when I pour water on that, then automatically the roof will move forward to protect the crops, and whenever there is no rain, then automatically is go back. And next, coming to the ThinkSpeak, right, so there we can see the data. Right, now the data is coming as we are places for moisture sensor 1 because the moisture content is available, and the next pH value, so we can see the pH value, and next solar panel voltage, and next rain sensor data, and humidity in percentage, temperature in degree centigrade. So if you want to download this data, means if you want to erase the old data, so now go to channel settings. Before that, go to data import and export, and then download the data. So once download is successfully completed, it will opening into the Excel sheet. So there we can see the number of entries along with so-called sensors data, as we should know that the field 1, field 2, field 3. So there we can get only field 1, field 2, field 3, because field 1 is temperature and humidity and rain, moisture, so like that. So there we can see the data of sensors data. Right, so along with date and time and entry IDs available like this format. And now go to the ThinkSpeak back, and now we can erase that. So for that, go to channel settings, and only do clear channel, don't do any other things, only do clear channel, and after that it will prompt us it's cleared now, and go to private view. So only access data import, export, download, and next channel settings, and only clear channel, and after that come to private view. There you can see the old data got erased, and after around 15 to 20 seconds maximum duration based on the network speed, the new sensors data will be uploaded to ThinkSpeak. Right, we got the new sensor data again. Right, thank you.